Today we'll build a real-time stock price monitor using Go and the Finnhub API. This is a powerful project for understanding how to use Go's concurrency features and fetch real-time data from an external API. Let's jump in. Our goal is to build a simple stock price monitor that fetches live prices of popular stocks and displays them in real time. We'll be using the Finnhub API, a free and popular source for financial data, and updating stock prices every few seconds. We'll also leverage Go's concurrency to efficiently handle multiple API requests at once. Our tool runs in an infinite loop to fetch live stock prices every 10 seconds. First, we define the packages we need, including HTTP and encoding JSON for making API requests and parsing JSON, time for setting intervals, sync for managing concurrent tasks, FMT for formatting output, and log for logging errors. Then we define a struct called stock. This is a blueprint that tells our program what information to store about each stock we're tracking. In this case, a stock will have two properties, a symbol which is a string like AAPL or GOGL, and a price which is a floating point number representing the current stock price. This struct allows us to store each stock's ticker symbol and latest price, which will make it easy to format and display the data later on. Next, we have an API URL constant that holds the base URL for the Finnhub API, which is the source we'll be fetching our stock prices from. Now let's create the fetch price function. The fetch price function is the core of this program. It takes 4 arguments: the stock symbol we're interested in, an API key, a pointer to a sync.wait group for synchronization, and a send-only channel of type stock. Channels are a crucial mechanism for communication between different parts of a Go program, allowing them to exchange data concurrently. In this case, the fetch price function uses the channel to send the fetched stock data back to the main part of the program where it's displayed on the console. The wait group is used to coordinate the execution of multiple fetch price Go routines and ensure that they all complete before proceeding. Inside fetch price, we first build the complete API URL by combining the base URL, the stock symbol, and the API key. Then, we use the HTTP GET function to send a request to that URL and retrieve the response. If there's an error fetching the data, we log it using the log library and return. Now comes the interesting part. The response from the API will be in JSON format, which is a human-readable way to represent data structures. We define a temporary struct named result that mirrors the structure of the data we expect from the API response. This temporary struct only has one field, current price, which is a float. We then use the JSON.newDecoder function to create a decoder object that can parse the JSON response from the API. We point this decoder to the body of the HTTP response, which is where the actual data resides. Then, we call the decode method on the decoder, passing in the address of our result struct. This essentially unpacks the JSON data and puts the corresponding values into the fields of our result struct. If there's an error decoding the JSON, we again log the error and return. But if everything goes well, we create a new stock instance using the fetched symbol and price, and we send this stock data through the stock channel. In short, each call to fetch price builds the request URL for Finnhub's API by combining the base URL, the stock symbol, and the API key. Sends a GET request, parses the JSON response to extract the stock's current price under the seed field in Finnhub's response. Sends the result through the channel, allowing us to collect multiple stock prices concurrently. Alright, now let's jump to the main function, which is the entry point of our program. Here, we first define the API key we'll be using. Remember, don't store your API key directly in code like this, in real applications. We then define a list of stock symbols that we want to track. You can modify this list to include any stocks you're interested in. The program then enters an infinite loop to continuously monitor stock prices. Inside the loop, we first create a new channel of type stock. The channel constructor make allocates memory for the channel and initializes it. Inside the constructor, we declare a channel that can specifically transmit data of type stock, which represents the stock symbol and its price. But you may wonder, why create a new channel in each iteration? The answer is, if you reuse the same channel across multiple iterations of the loop, you risk data races. Creating a new channel for each iteration ensures that each set of stock price fetches operates independently, preventing interference between different sets of data. It guarantees that the data flow for each set of stock price fetches is isolated and well-defined. Next, we declare a wait group, which is a tool for synchronizing concurrent tasks. We'll use this to wait for all the fetch price go routines to finish before proceeding. Then, we iterate over the list of stock symbols. For each symbol, we call the fetch price function concurrently using a go routine. We pass the symbol, the API key, the wait group, and the stock channel to the fetch price function. This way, multiple stock prices can be fetched simultaneously. Next, we use another go routine to close the stock channel once all the prices have been fetched. We achieve this by using a wait group.wait, which essentially pauses the main program until all the fetch price go routines have finished adding data to the channel. Once they're done, we can safely close the channel to indicate that there's no more data to come. Now it's time to display the live stock prices. We print a message live stock prices to the console. Then, we enter a loop that reads data from the stock channel. For each stock received, we print the symbol and the corresponding price. This loop continues indefinitely, fetching and displaying stock prices every 10 seconds until you decide to stop the program. So to quick recap in this loop, we create a new go routine for each stock symbol to call fetch price concurrently. We close the channel after fetching all prices. Finally, the data is displayed in real time, and the loop waits for 10 seconds before fetching updated prices. We've just created a dynamic real-time stock monitor. This program is a great demonstration of Go's concurrency strengths and its ease of use with APIs. This type of real-time data handling is widely used in financial technology applications where fast and frequent updates are critical. You could also expand this project to include stock trend indicators or volume data using Finnhub's additional endpoints. If you enjoyed this video, you will definitely love to watch other quick coding challenges on this channel. See you in the next video, and happy coding!